Okay, so here's the deal. I figured out how to make videos from home. And I know learning new material from home, trying to learn from videos and documents that we post isn't the easiest thing. So moving forward, I will try to make some short videos. I don't think they will be the entire lesson necessarily, but I think it'll be at least an introduction to each topic. But we'll figure things out as we move forward. We're really happy with how you guys are doing so far online. I know it's a huge transition, but we're all working together. Continue to post things in the Google Classroom, try to help each other out, try to Google things as much as possible, try to figure things out on your own, and then use us if you need us. Um, all right, so I think we posted the packet for the Unit 7. If not, we'll post it again so that you can follow along. This is Lesson 1, Introduction to Probability. So just fill out this do now really quick, and then I will throw the answers up and we'll move right into probability. So if you need to, at any point, pause the video so you can answer questions, and then unpause it, and you can listen to me do the question, and then self-assess your work or clear up anything you're having trouble with. How many possible outcomes can you get when flipping a coin? Well, there's two. It could be heads, it could be tails. That's it. An outcome is all of the possibilities that can happen when you do something. When you flip a coin, when you roll a dice, when you spin a spinner, those are all the possible outcomes. What do you think the probability of landing on heads is? Well, one of the sides is head. There are two total sides. So 1 out of 2. And you can tell how sloppy this is because of how I'm doing this. I'm doing it on the computer. So we're just going to have to deal with it. What do you think the probability of not landing on heads is? Well, not landing on heads, there's one side of the coin that is not heads, and 2 total. So again, 1 out of 2. Um, Probability can be written in 3 ways. It can be written as a fraction, a decimal, or a percent. So the probability, for example, of flipping a coin and it landing on heads as a fraction is 1 out of 2. As a decimal, that would be 0.5, and as a percent, that would be 50%. Those are all the same thing. Those are 3 different ways of saying the same probability. Um, if you have a spinner that has 4 equal segments, the probability of landing on the number 2 in that spinner, so a spinner I'm talking about that maybe looks like this, the probability of landing a 2 would be 1 out of 4. There's 4 sections, and only one of them is the number 2. As a decimal, that'd be 0.25, and as a percent, that would be 25%. We'll talk about that more in a bit. So what do you think it means to find the probability of something happening? And you guys do it all the time. Can you say, like, what are the chances of this happening, or what are the odds? That's probability. Probability is, um, well, no definition here. Probability is figuring out the chance that something will happen. So if you want to write that down, you can. Probability is figuring out the chance that an event will happen. There's a formula for probability. It is written right here in the middle of your page. Notice that it's a fraction. So all these problems that we're going to be doing today, you should start with a fraction. Do not convert it to a decimal or a percent unless the question asks you to. I noticed in the Edgelastic homework that a lot of people, for example, were turning like 3 out of 7 into 42%, which is not correct. Because technically it was 42.8%, which is 43%, but you're rounding it. Just leave it as a fraction. So the formula for probability is the number of desired outcomes over the total possible outcomes. So when we used our flipping the coin example, there were 2 total outcomes, so that 2 goes in the bottom. And if we want to land on heads, well, only one of the sides of the coin is a head, so that's why we put a 1 on top. So that's what it means by desired outcomes over possible outcomes. Probability is always measured from 0 to 1. We'll talk about that in the next slide. An outcome is the result of a single trial. So if you roll a dice, whatever number shows up on the dice is the outcome. And a sample space is when you list out all of the possible outcomes. So for example, if you flip a coin, the sample space would be heads and tails. If you roll a dice, the sample space would be 1, 2, 3, 4, 5, 6. So when you list it out like that, that's called the sample space. And when you write it, you draw curly brackets around it, just so that it becomes a set. But so again, sample space, you're just listing all the outcomes. So let's take a look at this bag. It has marbles in it. This should look familiar. It was in your Edulastic homework. We want to know the probability of pulling a red marble. Well, we know that we're going to make a fraction because you can see it written at the top of your page. Probability equals desired outcome, how many, over the total number of outcomes. And the way you write this is you write P, parentheses, red. And that means the probability of picking a red marble. Well, the bottom number is always the total. I can see in the bag that there are 7 marbles. And then how many of them are red? 3. Now I can write that as a decimal or a percent, but I don't want to because it comes out to a very long repeating decimal. It's better just to leave it as a fraction. Well, then it says, what's the probability of pulling a marble that is not red? So probability of not red. And in this bag, it doesn't really matter because there's only 2 colors, but if there was a bag that had red, blue, green, yellow, black marbles, then you would have to count up all the ones that were not red. In this case, we're just looking at blue. But again, 7 total. How many are not red? 1, 2, 3, 4. So 4 over 7. So the probability of picking not red is 4 over 7. So let me ask you something. If I told you, and let's say I didn't show you the bag, I got rid of the bag, and I said you have a bag of marbles, and the probability of picking a red marble is 3 out of 7, and the probability of picking a blue marble is 4 out of 7, which one's more likely to happen? Hopefully you're thinking about the blue one, because 4 out of 7 is a larger fraction than 3 out of 7. So the larger the number, the higher the probability, the more likely that something will happen. So tomorrow, if I told you there was a 10% chance of rain and a 90% chance of sun, which one's more likely to happen? The sun, obviously. There's a better chance that there's going to be sun. It's only a 10% chance. So one of the things that came up in the homework, and it wasn't clear, so I'm not too worried about it. When they ask you for the probability of something, they're asking for you to be specific. They're asking for the fraction, the decimal, the percent. When they just ask you about the likelihood of an event, they're looking for you to tell in words. So again, if I use that example, tomorrow there's a 10% chance of rain. 10% rain. How would you describe that in words? Is it definitely going to rain? Is it impossible to rain? No, but I would say that it is unlikely, or maybe even very unlikely. So that's, when you're talking about likelihood, that's kind of what you're talking about. You're using words to describe how likely something's going to happen. And here's a scale you can use to help you. So if something has a 0 probability, and it does happen, that's impossible. So for example, if I flipped a coin and I wanted it to land on the number 4, well, there are no numbers on coins, so that would be 0. It's impossible. So if something has a 1 out of 4 chance, think about that spinner we talked about earlier with the 4 sections. If something has a 1 out of 4 chance, then it's unlikely. It could happen. 25% chance, it could happen, but it's unlikely. If something has a 50% chance, that would be equally likely because, like, for example, a coin, heads or tails, you don't know which it's going to be. It could be either, but they're equal. 75%, that would be likely. It's probably going to happen. So if I give you a spinner, 4 sections again, and let's say 3 of them have the number 1 in it, and the other one has a number 4, the probability of spinning and landing on a 1 is pretty good. It's 3 out of 4. It's likely. And if something is definitely going to happen, it would be certain. Let's take our spinner again, and let's say the probability of rolling any number, of spinning just a number. Well, of course it's going to be a number, so that's definitely going to happen. So again, 0, impossible, 1, certain. And then everything in between, you have to use words. 50% is always going to be equally likely or equal chance. 25% unlikely. 75 likely. If you're like down here around like 10%, you can write words like very unlikely. If you're up here at 90%, you can write things like very likely. but usually you're okay with these 5 words: impossible, unlikely, equal, likely, and certain. So here's a question from your homework, but I think it's important to go through it quickly. Sarah's playing a board game. The probability that Sarah will score a point on her next turn is 1 out of 3. Which statement describes the probability that Sarah will score a point on her next turn? Well, 1 out of 3, if you turn it into a decimal, is 0.3 repeating, or 33.3 repeating percent. This is less than half. Remember that half is that midpoint. So you have that scale from 0 to 1, and then half's right in the middle. This is less than half, so this is somewhere in this section. So it could happen, but it's unlikely. It's not impossible. She has a 1 out of 3 chance, but it's unlikely because it's less than half. If it was more than half, something like 2 over 3 or 3 over 4, then it would be likely. Let me just move this question to the next page so that I have room to work. All right, which event is most likely to occur? So you have to go through each one, figure out the probability for each one, and then tell which one's most likely. So for choice A, flipping a coin and landing on tails, well, remember that one of the sides is tails and there's 2 total sides, so 1 out of 2. For choice B, choosing a marble out of a bag with 9 blue and 1 red, well, that's a total of 10 marbles. And marble being red, well, there's only 1 red, so that's 1 out of 10. Choice C, rolling a number cube with faces labeled 1 to 6, I think they mean a dice, and the cube landing on a number less than 6. Well, remember that a number cube or a dice has numbers 1, 2, 3, 4, 5, 6, and 5 of them are less than 6. So that would be 5 out of 6. And choice D, spinning the arrow in a spinner with 4 equal sectors labeled 1 to 4. So here you go, 1, 2, 3, 4, and landing on a number greater than 1. Well, that would be 2, 3, or 4. So that would be 3 over 4. And it wants to know which one is most likely, so you just look for the biggest number. And 5 out of 6 is the largest fraction on those choices. All right, so here you have data about 4 teams, and they give you the probability that they'll play in the championship game, and they want to know which of these teams is least likely to play in the championship game. Remember, I know I'm going quickly, so if you ever want to just pause the screen, read the question, do the question yourself, then unpause it, feel free to do that. So least likely, you're just looking for the smallest fraction, the smallest probability. So I look at these. 1/2 we know is 50-50, is 0.5, right in the middle. Well, 2 out of 3 and 4 out of 5 are larger than a half. 3 out of 8 is smaller than a half. Even if I don't turn them all into decimals, I know that. So the Bulldogs are the least likely. Computer program selects blue, red, or green backgrounds each time. The program was used 45 times. So 45 is the total. And they tell us that out of those 45, 12 were blue and 21 were red. And then they're asking about green, but we don't know how many were green, but we could figure that out. 12 plus 21 is 33. And since there were 45 total, 45 minus 33 is 12. So there was 12 green. I noticed that green and blue came up the same number of times. So green is just as likely as blue, but not as likely as red because red had 21. Okay, the next thing you probably saw on your Edulastic assignment and in the videos we had you watch was called mutually exclusive events. That is when you want either one or another event to happen. It's 2 events that can't happen at the same time, but you want to know the probability that one or the other could happen. So when you get to a situation like this, where you just want one or the other, all you have to do is find the probability of each one separately and then add them together. And that's what this up here says. The probability of A or B equals the probability of A plus the probability of B. So you just figure out each one separately, A, B, and then add them together. That's when you see the word or. There's going to be another situation coming up in a little bit. Let's look at an example. What's the probability of rolling a 2 or an odd number on a dice? So you have to figure out each one separately. So the probability of rolling a 2, well, how many sides are on a dice? 6. And how many of them have the number 2 on it? Just 1. That's a mistake that a lot of students make. They put a 2 up there. There aren't 2 sides that have the number 2. Just because it's the number 2, that's still only one side of the dice. And then we have to figure out the probability of getting an odd number. Well, remember on a dice, if I list out all the possibilities, how many of them are odd? 1, 2, 3. So that would be 3 out of 6. So then if I want the probability of 2 or odd, remember all you do is you take each probability and you add them together. Notice I did not simplify the odd one because I knew we were going to add them together and I like them to have a common denominator. Normally I would simplify it. 1 over 6 plus 3 over 6 is 4 over 6, and then that can be simplified to 2 over 3. So there's a 2 out of 3 chance that when you roll that dice, it's going to be a 2 or an odd number. And if you look up here where I listed out the possibilities, here are your 3 odd numbers, and then also the number 2. Well, that's 1, 2, 3, 4 out of 6. So that's another way of looking at it. So here's an example. Based on the data, what is the probability that the next cereal box will contain a blue or a yellow ring? So again, if you want to read the whole question, pause it, read it, think about it, try it, and unpause it. So they want to know the probability of blue or yellow. So remember to do that, we just find the probability of each one separately and then add them together. Well, the probability of blue, we look in the table, there's 15 blue rings, and how many total? I think we have to add, nope, we don't have to add them up, they told us there were 50. So 15 over 50, and normally I would simplify this, but let's do the probability of yellow first to see what the denominator is going to be, because we're going to have to add these fractions together. Yellow would be 5 over 50, got that from the chart. So 15 over 50 plus 5 over 50 equals 20 over 50, and 20 over 50 simplifies to 2 over 5. You also could have just added them right away. There was 15 blue, 5 yellow, so that's 20, and then a total of 50. Okay. This one question is about a company selling artwork. They tell you information that people who go to their website, 117 didn't purchase any, 24 people purchased 1 piece of artwork, and 9 people purchased more than 1. They want to know the probability that the next person will purchase more than 1. Well, remember, probability is always desired outcomes over total. So probability of more than 1 artwork. So I look and I see, oh, 9 people purchased more than 1. That's easy. I mean, I need the total number. They don't give me that. So to figure out the total, I have to just take all those numbers and add them together, and it comes out to 150. So it's 9 over 150. That's it. That's the answer. It's not a choice, but that's the answer. But you can simplify that. You can divide the numerator and the denominator by 3. You can get 3 over 50. Bag full of marbles. You have to find the probability of each and determine the likelihood. Remember, likelihood is using words. So at this point, pause the video. When you unpause it, in a couple of seconds, I'm just going to write the answers on the board, and you should just check your work. So I'll pause the video now. Okay, answers are up. Check your work. Notice for yellow, 0. There are no yellow marbles. So I could have wrote 0 out of 10, but It's just 0. It's impossible. And the last one, the probability of picking a marble, well, that's 100%. It's 1. I could have written 10 out of 10, but that just simplifies to 1. It's definitely going to happen, so I wrote certain. All right, we're looking at these bus arrival times. They want to know the probability that the bus will arrive at EV stop before 8:20. The key is it says before 8:20. So remember, probability is always desired outcome over total. So we want to know the probability of before 8:20. And it's going to be a fraction. We need the total and the desired. Well, the total number, you can just add up all the times, is 20. There was 20 days that they recorded the time. Now I need to count how many will be before 8:20. So 1, 2, 3, 4, 5, 6, 7. So 7 out of 20. That can't be simplified, so that's perfect. It doesn't say it wants it as a fraction, a decimal percent, so I would just leave it. That's it. Your final answer. Now, if you're someone who is dying to turn it into a fraction or a decimal percent, as a decimal, it'd be 0.35, and as a percent, it would be 35%. No reason to do extra work here. That's it. This quickly turned into a 20-minute video. Did not mean it to. You can rewatch any parts you want. You can skip ahead. Just watch what you need. But start posting questions on the Google Classroom in the stream, in the discussion board, and answer each other. That'll help you guys. It'll keep you engaged in math and help you with the lessons moving forward, because I know learning from home is something that's difficult, but a lot of colleges do it that way now. And a lot of things, when you get older, you're going to need to learn for yourself and figure out how to do things on your own. So this is going to be really good practice. All right, good luck. Do the Edge Elastic homework and reach out if you have any questions.